Introduction to Truck Scheduling Model. Log transportation plays a very important role in sawmilling supply chain. The industry is highly dependent on the raw material, and one mistake in this continuous delivery leads to a major loss in the profit. A lot of issues can affect the transportation cost, such as the distance between the forest and the mill, the weather condition, politics, and etc. These issues are considered in strategic planning ranging from 1 to 25 years. However, these decisions are often made within the forest management and harvesting. We are only looking at the operational planning in this case. The operational planning decides the detail such as the routing for the trucks. The transportation cost can be reduced dramatically by using the backlog tour, which means the truck picks up the supply in the forest and delivers to the sawmill. Instead of going back empty, the truck can go to another closer forest and deliver to another sawmill and so on. A typical case has about 20 to 150 trucks, 100 to 500 supply points, and 20 to 100 demand points. By simple calculation, the combination of the routes and trucks can go up to billions. And a multiple supply could be delivered for each demand point since there's only a limited amount that can be delivered with one truck. So which route should I use? And how many trucks should be used for one route? Can the boss just say, my instincts tells me to choose this route for the month? No, that would be ridiculous. This planning needs a precise preparation and calculation by formulating a model. To formulate a model, first, all the relevant information and data should be collected. Remember, garbage in, garbage out. For cases like this, it normally requires 2 years or more to collect all the accurate data, like available routes and trucks, number of supply and demand points, and their restrictions. Linear programming can be used to solve this problem. The decision variable in this case are if the trip is done or not, and they can be represented with 1 and 0, where 1 means the trip is done and 0 otherwise. The objective of the problem is to minimize the transportation cost, which is sum of the cost multiplied by routes. There are also constraints which are relevant to the problems. Typical constraints include each truck must only take one route, the limitation of supply volume, which can be represented with the number of logs picked up multiplied by the route, and that a total demand achieved. Since there are so many supply and demand points, we can get 140 to 750 constraints for the models. Now we have the variable, objective functions, and the constraint. And let's find out the solution by inserting all the data into a computer. Maybe we should fast forward this part. You see, most of the time, to find a solution of a model requires only a fraction of a second. But since we have billions of variables and hundreds of constraints, this case will require hours of time to solve. Oh, it looks like we have a solution. All the variables are either 1 or 0 to show if the truck should be scheduled for the corresponding route. This is just an example of the many truck scheduling models out there. These kind of models can help the industry to make the precise decisions, and most importantly, they get more money. Everyone's happy.